Yeah, this is COMP2404, Introduction to Software Engineering. Okay, so we're here on the 22nd. So we're going to finish overloading and then start on templates. So a couple things I want to address. So I don't know about the, I still don't know what you guys see on Gradescope, whether you can see your TAs or not. So if they've signed, obviously you can find their name. If they haven't signed, I can see their name. So, but what you can do is there's, I guess, a regrade option. So don't abuse this, obviously. If you want something regraded, click on the regrade and then give a good reason why somebody should look at this again, right? Don't just say, I think I need more marks. Say, you know, the rubric says this and I did this. I think you made a mistake or whatever. So yeah, that'll be the, I guess, workflow for getting your marks looked at, your midterms. If for whatever reason it's regrade, you don't think will work for you, then email me and I'll figure it out. I'll take a look at it either myself or I'll you know, ask the TA who marked it. Other than that, yeah. I think I'm going to extend the assignment 4 deadline. I'm sort of limited. I want to give the TAs a good week before exams to mark it so that otherwise there's, you know, possibly huge delays because now they have to arrange, you know, with their own exams. So yeah, I think I'm going to extend the deadline for assignment 4 till Wednesday. And yeah, that will be it. So that'll give the TAs 1 exact week to mark it. And then that means, you know, assuming we get to templates today, but perhaps we don't see all of templates today, then you have to wait till next week in order to learn about it completely. And so, yeah, just to be on the safe side, we'll extend it to Wednesday. So I haven't done that officially yet, but I will. The other thing I am going to do is I'm going to reopen all the tutorials. So if you're looking to increase your grade, that's how you do it. Okay, if for whatever reason you're not in a position that you're comfortable with, the late tutorial 10% still applies, but each tutorial is still, I believe it's 1.3%, something like that, or 1.35. So even with the 10%, that's still 1% per tutorial, right? So if you haven't done a tutorial and you submit it, then you get back like at least 1%. As long as you get a good grade on the tutorial. Okay, so that will address all of the emails I'm getting about you know, what do I do if I'm not really comfortable with where I am in the course right now? Well, the first thing you want to do is do all your tutorials. Okay. If you don't do all your tutorials and then you ask for some concession later, I'm not even going to look. I will check your tutorials to make sure you've done them. And if you have, then maybe I can hear you out, but otherwise, no. Okay, so yeah, I think that's it for what I have to address. Any questions? Yep. I'm going to open them up. I've been sort of considering, you know, how to approach the last couple of weeks. So you can submit them anytime up until, yeah, that's a good question. Up until, I would say the last day of class. The exam is the 16th here, right? Yeah, that's a good question. So it'll either be here or Saturday. Okay, so it can't be like, I won't leave it open past Saturday for sure. But probably Wednesday, because then the rest of the time you should be studying anyway. All right. Other questions? Okay. Last class we were talking about operator overloading, and in particular we got to these prefix and postfix increment and decrement operators. So the plus plus and the minus minus. And we saw a few examples of how to, right? So we saw some examples on our time class. So we had a time object called now, and then we could do things like add a minute to now, or subtract a minute to now using the prefix operators. And we saw how to implement those. There were two different ways to implement it. One was as a member function of my time class, and then the other was as a global function. So the member function does not take any arguments, of course, because it just uses this is the parameter. The global function, we need an argument, and because it's a global function, it's not a bad idea to make it a friend function so that we can access the private member variable. Okay, so then we wanted to, that's the prefix operators, and then we wanted to start on the postfix operators. So if we look at, and I'm just going to get rid of all of these for now. All right, so the postfix operators, again, we want them to behave the same way as integers do. So let's see. Okay, so I start with a 10 in my integer, and then I do a postfix increment. So this line here, I call 10 plus plus. It returns the original value of that was held in that integer variable. And then in the next line, it returns an 11. So it increments this, but it returns the old value. So that's the behavior that we want out of the postfix operator. So now we want to, again, we can do our little test-driven development here. So we have a postfix plus. Again, we want to overload this one as a member variable, and we'll do the minus as the global variable. So yeah, in order to denote that this is a postfix, we are going to supply an int as an argument, right? This is sort of a weird solution, but so this int doesn't really do anything. I can't pass any values in. I can use it, but it's there to signal to the compiler that this is a separate function from this. So that one is postfix and one is prefix. So all we're going to do, okay, so now we want an integer here. We'll call this dummy. And now since this is a postfix, well, actually we don't want to return. If we return the time object directly, we can only return it after we've incremented it. So the job is to increment the time, but we want to return the old time. So I'm going to make a copy that I return. Yeah. So I have this part's fine. I'm going to add a minute, but then I'm going to say time temp, and then temp.set time. Okay, so I've made a temporary variable that I've set to this. Sorry, I should do this after. Okay. So I convert my current time to seconds. I make a temporary time object. I set that temporary time object to the current time. I could have also done, you know what, this is a bit wasteful. Sorry. I'm going to use the, the copy constructor. So I'm going to make a temp time object that is the same. The same time as my current time, and then I'm going to set my current time to this time plus 60. So set time, convert to seconds plus 60. All right. I got that straightened out. And then I can return this temp time object. Okay, so I set my current time, I just convert it to seconds, and then I add 60 seconds to that. That will reset this current time, but before I did that, I made this temporary time object with the old time that I returned afterwards. Okay, so now this should run, and I should get back, oh yeah, Okay. All right, so then my integer, when I pass in the postfix int, I get 10, and then the next time I look at it, it's incremented to 11. And now the time has the same behavior. This is, I called plus plus, I called increment on that time variable, but it returned the old time. And then the next time I look at it, it has the new time. Okay, so, and all of that made possible by our dummy variable. Yeah, questions? Okay. Lastly, we will do the, the decrement as a global function, but we want the postfix decrement. So we're going to add this integer dummy. Did I get it? Maybe I got it backwards. Yeah, sorry, should be this way. Okay, so yeah, I add the extra integer dummy variable. It's still a unary operator. It only takes one operand, which is this time object. But I'm going to pass in the dummy variable so that the compiler can tell it apart from my other function. And then I'm going to, where is it? I want the same sort of behavior here. Time temp. I will store the current time, set time. Oh yeah, sorry. T dot convert to seconds minus 60. I'm counting on this set time function to sanitize that data for me. And then I'm going to return T. Not this, sorry, T. Okay, so now I have a decrement operator. It should store the old value into a temporary time object. Take this time object that I'm operating on, reset the time to a minute ago, and then return the old time. And, okay, so now we can see. Okay, so my, no, it didn't work, did it? Now. E dot set time, convert to seconds minus 60. Oh, I returned T. I should return temp. Yeah. So I had, yeah, it was decremented, but I was returning the wrong one. Yeah. All right. Okay, so now my postfix decrement for the integer is 11 followed by 10, and I get the same behavior with my time object. It's 1229 originally. After I apply the decrement, I get 1228. Okay, so that's all the increment and decrement operators, postfix and prefix. Any questions? Okay, so the next thing we want to look at is yeah, so this is the postfix and prefix. So we have to create a temporary object. This makes the postfix a little bit slower than the prefix and a little bit less efficient in terms of memory. So we should always use prefix operators where possible, especially if we're interested in, efficiency. And yeah, the difference in terms of the compiler is one int parameter. That's a dummy variable. You can actually use it if you like, but you can't pass any values into it. You can use it within the function to store things or whatever. But so yeah, the last thing we're going to look at, the last operators are, well, we're going to make some smart pointers. Okay, so we've been managing our own memory thus far in this class. Out in the real world, it's really rare to see raw pointers, but it is useful to know how all this memory management stuff works because you can still abuse smart pointers, right? They're not foolproof. You can still end up with a seg fault, for instance. If that pointer goes out of scope at the wrong time, then you delete some memory and then you try and access it later. So what we're going to do is we're going to overload these basically pointer operators, right? So the arrow, the dereference, and the address of. So we're going to make a class that acts like a pointer, but deletes memory that has been dynamically allocated, but deletes it automatically as soon as it goes out of scope. Okay. You can also make reference counting pointers. They're not that difficult either, but this will be good enough for here. So the first thing we're going to do is, well, we have a time object again. We're going to make a now, whatever, that's close enough. And we're going to just overload the arrow operator. Okay, so we want to be able to treat this like a pointer by using the arrow operator. Now, how this arrow operator works is that it repeatedly calls this arrow operator function until it finds a pointer, an actual pointer, right? So this is an object that is going to behave like a pointer. But yeah, this is basically a chained call of these arrow operators until it gets an actual pointer. So what we could do if we wanted to, and there's no good reason to do this, but just for fun, we can overload this operator in our time class, right? It takes no parameters, and we just simply return this, right? This is a pointer. So I can return a pointer. Once it finds a pointer, then it follows that pointer to the object. But yeah, this is, again, there's no good reason to do this. But what it means is that now I can call this print function using, instead of, the classic method, since this is an object, I can make it behave like a pointer using the arrow operator. Okay, so let's see. Okay, so printing from the arrow, so you can't really see. So we get 10, 10, 10, and then I can print using the arrow operator. So yeah, that's, no great trick there, but we're going to use that now in our smart pointer. But any so far? Okay, so I'm going to make a smart pointer object, and what I want is, I want to be able to do this. This is an object, but I want to be able to assign it a pointer to a time object. And then this smart pointer is going to behave exactly like a pointer. I should be able to do all of these different pointer operations on it. And these should all work. But then once I return, I don't delete it, but it's going to be deleted for me. Okay, so that's the idea. So in my smart pointer here, I want to, well, the first thing I want to do in the constructor, I want to be able to assign it a pointer. So I'm going to need to store a pointer in a member variable. So T. So that's going to be, what we sort of fake all of these operations on. Here I'm going to say time T equals null pointer. So I'm going to, take one time pointer as an argument. And if I don't get a time pointer, I'm just going to assign it a null pointer. And then I'll say, right, I'm using member initializer syntax here just to initialize this member variable. So now this member variable either gets a time pointer or a null pointer. So I'm all set here. The other, in order to make this a smart pointer, again, I want this deleted automatically. So I'm just going to delete T. This may or may not work with the null pointer. I've had mixed results. So yeah, the mileage here may vary. Otherwise, you could do a null pointer check before you delete. But some versions of C++ allow you to call delete on a null pointer and not suffer any consequences. Okay, so I've managed the memory. Now I want to overload the arrow operator. This should return, again, it returns either a pointer or something else that overloads the arrow operator. In this circumstance, I have a pointer. And I'm just going to make all of these inline functions just for simplicity. So I'm just going to return, if somebody calls the arrow operator on this smart pointer, I'm just going to return the original pointer. And then the code will follow the original pointer to the memory location and grab the time object and then call whatever operation on it. Okay. I also want, well, in my, what's the problem? Yeah. So it doesn't like this. I haven't overloaded the dereference operator. The arrow is working. So yeah, let's just do the dereference operator and then go, test it. So dereference should return what? So this is supposed to behave like a time pointer. So if I dereference a pointer, yeah. Exactly, yeah. So it should return, we want a dereference to return a time object. So we're going to return it by reference. And then, so here I will return, well, I want to return my, sorry, I'm in the wrong, mission. Okay, so I'm just going to, I have my time pointer. It points to a time object, presumably. So I'm going to just return the dereference. I should really do a null pointer check here. But, you know, for our purposes, this is good enough. Okay, so I have this dereferencing operator. Now what's the problem? Oh, my print should take a. All right, so here I dereference my smart pointer and I return back the time object. That time object gets sent to C out, right? So I'm going to print it once here, and followed by an end line. In this line, oops. Sorry, in the next line, I dereference my smart pointer. Again, this returns a time object. I have it in brackets and then I use the dot operator. So this, you know, this should work with any pointer. And I also use the arrow operator. So I print it out 3 times and I think I have to, it would be a good idea to add a bit of formatting. Okay. All right. So all of these print operations should work. Hopefully. Okay, so printing the time pointer using the smart pointer, all 3 of these work. So now I have this thing that behaves like a pointer. I can assign it a new time object. So this calls the constructor. I should also overload the assignment operator, right? So then it takes a pointer as an argument and then assigns it to my t variable. In the interest of time, I won't do that right now. The other nice thing about it, if it's a, if I run valgrind on it, I have no memory leaks, even though I didn't call delete. In my main function, I called this new, I assigned it to my smart pointer. The smart pointer managed the memory for me. And that's basically exactly how smart pointers work in C++. Yeah, questions? Yep. Yep. So yeah, we're going to actually take this code. When we learn templates, we're going to modify it and yeah, make it so that we can store any type of pointer. Yeah. Other questions? Okay. Yeah, again, there's also reference counting pointers. It's a little more complicated, but not too bad at the end of the day. Okay, so that brings us to the end of operator overloading. As you can see, that is sort of a very rich area of C++, and it has a bunch of just sort of, I guess, frivolous operators, frivolous as in you don't actually need them, but they're kind of nice, to necessary operators such as the stream insertion operator, and of course the pointer operators if you want to make smart pointers. So now we're going to start in on templates. This is, one of the last, probably operator overloading and templates are the main components of your assignment 4. So templates are, well, we're going to, give an overview of what they are. Sorry, my pen has been malfunctioning. We're going to look at function templates and then class templates. All right, so you can, well, we'll talk about what templates are, how you apply them to a global function, and how you apply them to a class. Then we'll look a little bit at the STL vector class, because this is a template technically, and we'll also look at smart pointers. At the end, we will apply our template knowledge to smart pointers so that we can store anything. Okay, so some of the principles of object-oriented design, if you recall, are data abstraction. So what that means is that when I write an algorithm, right, typically we've been talking about polymorphism up until now. So I write an algorithm on a general base class, and then when I run it, it calls the specialized derived class functions. We want to do something similar here, but on I guess, in a different manner. And code reuse, right? So when I have a algorithm that I've tested many times, it's in part of a library that many people have used, then that becomes very, very reliable. And it's a good idea to reuse it in your code because, well, you're not going to introduce bugs into that particular part of your code. So yeah, reuse existing code in your programs and make your classes reusable. That's why we've been building our own data, our collection classes, but generally speaking, you don't do that unless you need something very specialized. You usually use vectors and linked lists and so on that have been made for you. So mechanisms for code reuse, well, existing libraries such as the STL library, which we're going to see a lot of coming up. And again, they're generally well made. If for no other reason than many people have used them and found all the bugs. And then another mechanism is generic or template programming. So generics, you guys have taken Java, so you've most likely seen generics. In C++, they're called templates, and we'll talk about why they're called templates. Everything is called something in C++. However, C++ came before Java, so what are you going to do? So yeah, the idea is we want to write general algorithms that can be applied to multiple data types, right? So our smart pointer, there's no reason why that would only work with a time pointer. We should be able to, that should work with any pointer. I mean, all I'm doing is just forwarding calls to whatever that pointer, I'm just returning a pointer or I'm returning the object and that's it. So yeah, we want to be able to write more generalized algorithms. So what is a template? Well, in general, it's something that, serves as a pattern, right? So I have a template to build a house, or not maybe a house, but something more simple than that. And I can just make copies of it by following the instructions. So what we do is something similar. We write code with general placeholders for the types. Now, these are not actual, as we'll see, they're not actual functions and they're not actual classes, right? They don't compile until you provide a type, right? So these placeholders are later filled in by the compiler. You cannot compile them if you don't put a value in there. So our goal is to write algorithms, reuse on different data types. So that's pretty straightforward, but yeah. And to do that, our data type is a parameter. So we're just going to pass in this parameter to our compiler and say, make me a class that looks like this, but replace the type with whatever I supplied. So yeah, so these are called templates. They can be a template on a function or a template on a class. In C++, I can use templates with any data type, right? It's not restricted. Well, it's not explicitly restricted. It's implicitly restricted if it doesn't compile, right? So the compiler is going to go through and copy and paste all of your placeholder values with an actual type, and then try and compile it. And if it doesn't compile, that's where it fails. But there's nothing to stop you from using any type you want there explicitly. There's nothing that will explicitly stop you. Okay, so any function can be made into a template. So global function or a member function. But if it's a member function for a class or a struct, then the entire class must be templated, right? So templated is sort of a verb in this case. All right, so yeah, there's a bunch of reasons for this. We'll talk a little bit more about what's happening, but first we'll look at the first example. Oops. Yeah, okay. Okay. Good. All right. And I will. Okay. So we have here, we have just a very simple little piece of code. So we have a main function here. And in this main function, we call on a max function. And this max function, we can see we've forward declared it here. So it's just, it takes 3 integers as arguments. It returns an integer. So here I call it with 33, 22, 44, and it should return and print out the maximum of these numbers. Okay, so if we look at our max function implementation, I have v1, v2, v3. I have a variable called max value that I initially set to v1. And then I compare that max value against v2 and v3. And if v2 or v3 are greater, then I just, I swap that value, right? So this is pretty standard max function. And if we run it, the max of 33, 22, and 44 is 44. We can see that it works, at least in this case. Okay, so simple so far. What we want, though, perhaps, is we want this to work for floats. Maybe or doubles. So maybe we change these values a little bit. Uh, 3F. So again, the F is to say that this is a float, because by default, these will be doubles. All right, so will this work? There might be an implicit conversion that happens, actually. No, okay, it doesn't like it. All right, so what I want to do is I want to make a second one of these functions for floats. I want to change this. And all of these. My function declaration similar to this, except I replace with floats. And then I have to make a new implementation. But you'll notice the logic, if I use floats, the logic is basically the same, right? I'm not going to, yes. I'm not going to change int with, and then I need to do nothing else, and this will work as advertised, right? The logic is the same. The less than works the same in floats as it does with integers. So now my max function returns 44.4 as a float. Great. So that works, and there's, we're reusing code, which is sort of frowned upon, but generally speaking, what choice do we have in this case? But yeah, so now maybe we want to compare characters or maybe time objects, right? So what we just did is what the compiler does when we make a test. We're going to do, instead of making all of these functions, since the logic is always going to be the same, I could do the same thing with characters here. I'm going to make a templated function. So I'll call template class T. Get rid of this. And then in place of float, I'm going to use T. So T is my placeholder type or class. Okay, and then I'm going to go delete this. And here I will say replace T with int. And then, yeah. Okay. So up here where I declared my, that'll be fine. So up here where I declared my function, I declared that it was a template as well, right? So here the compiler knows that T is just a placeholder, so it's not going to go looking for a T. It knows that I'm going to give it one later. I have to do the same thing here. Class T. Here I'm going to use type just for fun. So I have to have a template declaration here as well. Sorry, type, what is it? Type name. Okay. All right, so I have my function declaration. Declare that this is actually a declaration for a templated function. And then in my implementation, I also declare that it's a templated function. Now, instead of an actual variable, right? These are no longer working functions. And then when I call these, when I call max using ints and call it using floats, well, since the logic is still the same, it should work. So let's try it out to make sure that it does. Okay, so my max function still works, and now I have only one version. Okay, so what happened here? Well, what happened is the compiler did exactly what we did. All right, the compiler is not that smart. When we called this function with integers, it takes a look and it finds, well, first of all, it looks for a max function with integers. It doesn't find it, but it finds a function template that matches this signature. So it goes, okay. It comes down here, it copies all of this code, it pastes it, it replaces the T with int, exactly like we did with ints and floats, and then it compiles it, right? And then after it compiles it, when we run the code, it runs, and then it comes down to this line, and it sees, I have 3 floats. Again, it sees it has a template that matches this signature. It copies and pastes this code, replaces the T with float, tries to compile it, everything compiles, so it says okay. And then when we run it, we have this function call and this function call are actually 2 different function calls. And the compiler did what we would do, is simply copied and pasted and replaced all of the types, right? So it's not, the compiler is not that smart, but it is smart enough to do that without making errors, right? So, humans are error prone. The compiler is much more reliable at it. So it's not really efficient in terms of, I'm not running a single function. When I call these, I'm making 2 different functions, but the compiler is handling all that for me, so I'm happy. Yeah. Right. So let's try it. Okay. So because we're using, so the compiler or the, C++ VS Code is smart enough to be running the compiler in the background. So it says, yeah, this is not going to work. Yeah. So I can't mix and match, right? If they're all T, it's control R, find replace. Control R doesn't work on the VS Code, but any other editor it would work. Other questions? Okay. All right. So then I mean, we should be able to do this now with characters, right? Without actually making any changes. So I could say A, B, C, and then actually, let's make this one A. We're always returning the last one. All right, so I can compare A, B, and C. And this will work because the less than operator works. Yeah, so C is still the greatest. Right, so all it does, it copies and pastes character in for T, and then it tries to compile and it sees, yes, there is a less than operator for my character class. So this compiles. And that's basically it. The other thing we can do is, well, we have a time class. Now, I don't have an overloaded operator, but I can make one. Right? All I need really is that less than operator. And I will just do return. Do I have convert to seconds here? Yes, I do. Convert to seconds less than t dot convert to seconds. Right, so again, I'm just forwarding it to the integer less than. But now that at my time class, well, if I substitute time in for t here and I look at all the operations that are called on it, then this will compile because I've overloaded this. So I can make 3 time objects. And let's do, we can, what does it take the year, I guess? So 2023. Okay, and then I can call max time object. Okay, and it looks like it's compiling properly, but let's, we've also overloaded the stream insertion operator. So the maximum time is 0 time. So I'm thinking, sorry, I'm thinking date time. What do we have here? Yeah, so I just need 23, 22, or 21 should be good enough. Okay, so the maximum time is 23 o'clock. But yeah, it works for our time function as well. Or sorry, our time objects. In fact, anything that can copy and paste, any value, any type that I can copy and paste in here, that will compile, will work. All right, questions? Okay. All right, so the other thing, all right, so this is sort of a review if you're trying to study. So I guess one thing we'll come back to, I declared a template using 2 different methods, right? I said type name for the implementation, and I said class for the declaration. Well, I can also do this. Two, or I can make them both the same. For this context, type name and class mean the exact same thing. When I'm declaring a template, if I declare a class or I declare type name, they mean the same thing. These keywords are different in other areas, but here they're precisely the same. All right. So yeah, every time I declare a templated function or a templated function implementation, I have to declare the template. And then, yeah, what happens is, well, I write a function with a placeholder, a T in this case. And then what the compiler does, creates a separate function for each time I call it with a different data type, right? It does a find replace on the T with the type that we call it with, and then it tries to compile it. If the code doesn't compile, we'll get a compiler error when we compile it. But if it compiles, then we get a brand new function with a brand new type every time. Unless I call it twice on ints, then it uses the same function. So the compiler generates functions only for types that appear in the code, right? So if I don't actually call this max function, it never gets compiled. So there's no actual function called max in existence until I call it. This is important. This is when we get to class templates, this is why your array.h, you have the declaration and the implementation together. I'll explain it when we get there, but it has to do with this, right? If I don't actually supply a type, if I don't actually call it with a type, then nothing gets compiled. All right. So we can overload templated functions with non-templated functions. And when we do that, the non-templated function is chosen over the templated, right? So what does that mean? Well, if we go back to our example, here I have my max function on type T, but I could call, maybe I have it actually already made. Nope. All right. So what I can say, well, int max, int, right? So maybe I don't like this particular templated function. Maybe I want to make my own for integers that's going to behave a little bit differently. So I'm just going to write an implementation for it. And then, yeah, this has to be an int as well. This works, and then I can say in here, in non-templated function. Okay, so now I have a templated one and a not. Well, I call the non-templated one first, or what does the compiler do in this case? Well, it goes looking for a max function that matches these parameters, and here it finds one. And that's as far as it goes. So if I only call it on integers, this template never gets used, right? So the first one will print out a little bit extra. The other two will not. Right, so the first one in the non-templated function, and it returns 44. Here it returns 44.4. So these are the templated versions, and this is the int version that we wrote. So we can overload it with templated functions with non-templated functions, and the non-templated take priority. All right, questions? Yep. Oh, sort of like in Java with the ... or whatever. I imagine you could. I would have to brush up on my C++. But yeah, and then the question is, would that work for templates, right? So I'm sure if I had to hazard a guess, I'm sure all of that's possible. I don't know off the top of my head how to do that. Yeah, that's a good question. So yeah, the question was, can I make an unspecified number of parameters like you can in Java? And my answer was, I'm almost certain, but I don't know how. I would have to look it up. Other questions? Okay, and we could also do things like int max. Right, so the compiler is not going to care about this. I can overload it with a different function signature. That's also okay. Yeah. Okay. All right. So that is function templates. We can also have class templates. So our goal is to create a class that works with any data type. When we instantiate a version of this class or declare a version of this class, we have to specify a type parameter. Okay, so similar to the function, when we call the function, that's when we tell it what the type is. When we declare our class, that's when we tell the compiler, okay, I need a class with this type. And again, what's going to happen is I'm going to have this placeholder parameter in throughout my class. The compiler is just going to take your class, going to copy it, paste it, find replace on that type, and try and compile. And then, yeah, so this is where, this is why linking doesn't work, right? So let's go through this example, and then we'll talk about why we include everything in the same header file. So what we can do with class templates, well, this parameterized type can be used anywhere in the class. I can declare data members of type T in this case, or I can have function parameters or local variables be of that type, right? It's just a find, replace. Anything I could do with a regular type, I can do with this placeholder type. So where this is most useful is collection classes, or this is, where it sees a lot of use. So vector, for instance, if you use a vector, I have to declare what type. So vector is a template, doesn't exist as a class until I make a declaration, and then the compiler goes, grabs all the code, copies, pastes it, does a find replace with int, and then compiles it, and then you have a brand new class that works with ints. So yeah, let's take a look. Okay, so arrays are what you guys are doing. We're going to do a linked list here as an example. So currently this linked list, right? So we're not going to go over how all of this happens. Hopefully you remember. All we're going to do is we're going to change this into a templated list class. So currently this is a list on type integer. So my data type is integer. So this is a linked list of integers, and I can do, I have an isEmpty, I have an operator, subscript operator, I have an add, and I have a remove. This is a little ambiguous, but it removes, it finds the int of this value. This is not an index. When we change it to a parameterized type, this will become more clear. As it stands, a comment here would be a good idea. So yeah, this is a list of ints in my main function. I make a list of these ints. I add 5 ints to it. I print them out. Is my print function working? I did not. Okay, yeah, there was a reason I didn't do that. Okay, so what I want to do here is I'm going to implement this stream insertion operator for my list. So I want to declare a node. Now this is a friend function to my linked list. And so I want to do something like this. Node current, right? So I'm going to basically do a traversal of my linked list. So I need a node, sorry, this should be a node pointer, equals list.head. That's what we want to do, but the compiler doesn't know what we're talking about because it doesn't know what a node is in the context of the list class. What I'm going to say is, well, I'm going to use the scope resolution operator and say, well, if you look in the list class, there is a node. I'm a friend of the list class, so I can use it. So here, I'm going to grab it. This will become important later on. You can see this works here. This will stop working for a little while later. And then I'm just going to print everything. So I'll say while current is not equal to, oops. Null pointer, null pointer. Okay, so while it's not equal to null pointer, I will simply print out current data. Yeah, let's do an end line. Okay, very straightforward, simple. Now my print function should work. So yeah, I add a bunch of ints to my list of ints, and then I can print it out. Okay, so let's try that. Where are we? P3. Oh yeah, I always forget to return that output stream. Now, luckily, the compiler is smart enough to catch it. Oh, right, something's wrong. What did I forget? Yeah, I forgot to update my current pointer. So current next. All right, that is, yes, the error that I seem to make every single time I do this. Okay, so I print them out. What did I do precisely? Yeah, so I added them, I printed them out using a for loop, and then I printed them out using my overloaded stream insertion operator. They both printed out the same set of numbers, 0 through 4. And then I got a segmentation fault. Beauty. Where did I get that? Is here somewhere I got it? Oh, why am I using cout? OST. All right, I'm just going to take a quick look for the segmentation fault. If I can't find it, we will proceed. But oh, okay. So it's something to do with cout here. All right. Okay, so everything's working fine now. So now I'm going to template my list class. Okay. All right, so I want to change this entire list class so that, well, I have here a book class, right? So this is, we've seen this before. We've overloaded the stream insertion operator. Yep, I did. Okay, so this is a book class, and what I want to be able to do in my main function is I want to be able to make a list of books, right? And then I want to be able to add these books to this list. I haven't declared it, but I want it to be a list and then of type. I want it to look something like this. So I'm adding a bunch of book pointers, list books. Okay. Obviously, the compiler doesn't know what I'm talking about here. I've included this list class, but I want to template my list class now. All right. But first, any questions on what we're doing or what we're trying to do here? Okay. So I want to change my list class into a class that will take any type. So I'm going to say template class T. This will be a list. Now, yeah, my entire screen turns red. That's okay. We're going to fix all of that. Mostly these are implementations where I now have to declare them as templates. But the other thing I have to do is, well, let's start at the beginning. This, I want to return of type T. I'm going to return by value for now. I want to add type T and I want to remove type T. Whoops. And remove and return, I believe. Okay, so this is what my function implementations will look like now. My node will have a get of type T. And this is all fine. Yeah, so I need to declare all of my implementation as templates now, which this clears up some of it, but now I also have to say, this is no longer a list type. This is a list angle bracket T type. And so I have to change all my scope resolution operators to look like this. But we can see there, nothing really changes. My destructor. So what do I do in my destructor? Well, everything looks fine, actually. I've never used ints directly here. Nodes. Nodes aren't of type T, so I don't really have anything left to do here. My is empty. I declare it as a template. This is type T. Again, data doesn't show up here anywhere. The T doesn't show up here anywhere, so I don't have to change any of this code. This, I might have to change something. Here, I wanted to return type T. It's incompatible, yes. Oh yeah, so this is supposed to be an index, sorry. This should be an int still. Okay, so now if I look at this, the code, again, I'm not really doing a close inspection. I'm just looking for any integer. Basically, I'm looking for any red, but there's no red in here. I go through and I look for the correct index. When I find the correct index, I check if the current node is null. Return current node data. Well, this data matches my return type of T, so that works. I don't have to change anything else here. T here, I have to change. This is, I'm not. So I make a new node. I assign the data type T. Everything seems to be working in that function as well. So in this one, I am. Oh, this is an index. Okay. So this is an index. I'm going to return of type T. Let's make sure that matches. Remove int. So I remove whatever is that index. Return it. All right. So then if I look at the code here, well, current index is less than index. I find it if the current node is equal to null, then I return that it's. Otherwise, yeah, this should be now. So goner is now of type T, and I got to return the goner. Find the correct index. I grab the value from it, which is of type T. I do some pointer operations to remove that node. I delete that node, and I return the data that was there. Okay, so this is just linked list implementations. All right. So far, so good. Questions so far? All right, so simple. You should be able to do that with the array class, no problem. Again, just make sure that the remove is whether you're removing by index or by type. I think in the array class, you remove by type, but you don't really have to change the logic at all. Here now I have a global function. This is going to be a templated function as well. Now this list class is no longer type list, it's of type T. Okay, so a couple things are happening here. One is, all right, well, we'll come back to this. Now this has to be list of type int. And then if I do that, this should all still work. Okay, so I've gotten rid of, I made a list of book pointers. I've added some books to that, but I haven't printed them or anything. My list of ints should still work the same for my templated type. There's going to be a couple errors here, but we'll get back to them. One is that now my list is no longer of type list, it's of type list T. Well, I have to make sure that this is of type list T as well, but let's, for now. All right, so we get some errors. Yeah, this one I expected. And then this is giving me a warning that this list type is not. I took a look and it said, you probably meant list T, but I'm not going to correct you if you don't want me to. Okay, so I want to make this of list type. But if I do this, well, watch what happens. Let's try and compile that. Yeah, so now it's giving me another warning, making sure that, did I really mean this? Because what's happening here is that, okay, first of all, I have to, this is not reading correctly to the compiler since I'm using this type T here, right? This is, in some sense, it's a forward declaration of this function. So I can't really declare it with type T because this is a templated function. I have to declare it as a templated function. And now if I do this with the same type T, well, now this T is a different parameter and I've hidden this other type T. So I've shadowed the type T with this type here. So it might seem a little bit weird, but the compiler's not going to like it. So what I want to do is, if I declare a friend function inside my templated class, I have to use a different variable for the type. Okay, otherwise it's going to hide this type here, and then I won't be able to access that special type for my class. So this type here and this type here are separate as far as the compiler is concerned. Now, when we implement them, they'll be the same, but yeah. Questions? Yeah. Yeah, so the fact that so that's a good question. So I declared it as type V there, and here I declared it as type T in my implementation, and that doesn't matter. I could declare it as type V as well, or type T, or, type tree, whatever I want. As all of the T. Yeah, good question. Other questions? Yeah. Oh, yeah, I do actually. Yeah. But yeah, the reason why that wasn't coming up is because the compiler is confused here. So yeah, that is a good point. I do have to list this using my scope resolution operator as a list of type T. But you can see this is discolored. So the compiler is still confused here. So let's just, yeah. So it says, parsed as a non-type, but instantiation yields a type. So what the compiler thinks is that I'm grabbing some variable from my list class, and I'm trying to multiply it by this current. So that's what it's parsing. And it's saying, well, it doesn't like that. So here I'm going to actually say, I'm going to help the compiler out. I'm going to say, this is actually a type. It's not a variable. So you can't multiply it. This is this is a type, not a parameter, or, not a variable. C++ is weird. In this situation, this is ambiguous. The compiler can't always decide what this, when I have a templated type and I declare a pointer, it thinks that this can be a multiplication, so I have to tell it that this is a type. All right, these are sort of deep subjects, but it's good to be aware of them. So now everything seems to compile. All right, so let's just run that. Okay, so all it's done so far is print out my ints. It did make a list of books and add them up. No, but I haven't done anything with that yet. But any questions so far? It's a lot of technical details. You just got to remember them. You don't really have to you don't have to understand everything about them. These are just sources of errors that you might come across yourself, and I want you to kind of, know how to handle them. Okay. So now I'm going to take my list of books. I'm going to print them all out. All right, so yeah, my books are up here. My ints are down here. Let's just take those out. Let's leave this one in. Okay, so now I just have a list of books and I print them out. And so I have a linked list now that works with any type. And really, I don't even use any functions from that data. I just return it. So I can basically store anything I want here. I can remove the third book. So I can print out the third book, remove it, and then print out the list with the removed book. Yeah, so my print is, what did I do here? Oh, my list of books. Yeah, my list of books prints differently, doesn't it? So yeah, that was on purpose, I promise. So yeah, it worked fine before when I overloaded that operator for ints. But now what it's doing is it's printing out pointer addresses, right? Because, well, if I can store anything in my linked list, then I can store a book, or I can store a pointer to a book. And which should I do? If dereference, then this will not compile unless I store a pointer, right? So it seems a little bit weird but if I have a templated collection class, if I overload that output stream or the input stream operator, I don't want to assume that's a pointer. So I just want to print whatever it is, and I'll let the user, whoever instantiates the class, take responsibility for printing it correctly. Yeah, in fact, for things like vector, if you do this, you are supposed to overload the output stream operator for a particular type, right? So if I store a vector of ints, then you can just overload the stream insertion operator for ints and have it print correctly. You can do the same thing here. All right, questions? Okay, so that should, yes, I did want to get there. Should give you probably everything you need for your assignment 4 in terms of templates. I'll talk briefly about what's happening, why I can't, well, it's not that I can't, but why I put the implementation and the declaration together. So typically what I would do if I had, I have, say, let's say a bank, and then I have a collection of bank accounts, right? So list of bank accounts. Okay, so typically what I would do is I would compile them both to, well, I would compile bank. And then I would compile list.o, and I would link them together, right? So here I need source code, but this class does not exist, right? So this is a templated class, and the compiler doesn't make any templated class unless I declare it specifically. So this should contain compiled code, but what compiled for which type? The compiler doesn't know. Right, so there's ways around this. If you know what types you're using, then you can actually make an object file for a templated collection class. But if you don't, then there's no way to compile this into an object code without telling the compiler which type to use in order to compile. Right, so that's why for these templated classes, we include the implementation in with the header. right? And then this is basically everything we told you not to do, but we will, include list.h. This has the header and the implementation in it. So when we compile our bank class and we declare a list of type bank accounts, well, then the compiler can compile that code, right? It can make a list class now, and it can compile it against the bank account type and make sure everything works. And then basically all of this code is in bank.o now. There's no list.o in this case. So that's why we do it this way. Again, if you know the types, you can get around it well, there's ways around it, but yeah. Any questions? Okay. All right. So yeah, with templated classes, we're going to include the implementations in the header file. Can cause problems. That's, again, the compiler doesn't know what type to compile. So the .o file, it needs to know what type to use. So yeah, we're just going to avoid those problems altogether. The other thing to keep an eye out for is, if I have an array class, which you guys will have, and you overload this stream insertion operator, this has to be different from this, right? Because these are two different variables as far as the compiler is concerned. And if I make this class T, then it hides this one. And then I can't use T anywhere in my array class. So yeah, that's the other weird thing, is that if I declare a friend function, I have to declare it as a different templated type. And the other thing I touched on is when I declared templates, I can declare it as a class or a type name. These are exactly the same. The one place where it became different, right, was in the overloaded stream insertion operator, where I needed to tell the compiler, hey, listen, I'm not doing multiplication. This is actually a type name here. And then once I do that, then the compiler knows how to compile it. Otherwise, it's ambiguous. Now, how is that ambiguous? I don't know. I'd have to look a little deeper into it in order to find an example where it would be ambiguous. All I know is, well, whatever. I read Stack Overflow too. That's what they say. So that works for me. There's a good Stack Overflow post outlining some of the differences between type name and class. Mostly they're interchangeable, except for here. Okay. So yeah, class template, how we implement it. We write a class with the type variable name. Then we can declare an instance of the class using any type. And what the compiler does is it makes a new class for every different type. So my list for books was a separate class for my list for ints. And if I made a different list, that would be separate as well. Right? So the same as where it makes new functions, it makes new classes. So all of your class variables will be separate. If you have something like a next ID or something like that, it'll be different for each type. So you have to be careful of that. All right, so next week we'll look at some more class templates. We'll look at multiple types. We'll look at, well, we can have non-type parameters. We can pass in integers or whatever values we want. And we can also have default types. So yeah, we'll look at that next week though. So yeah, this week is some tutorial, I forget, but yeah. So don't forget to get that in, and I'll reopen the tutorials and change the due date for assignment 4. But other than that, have a good weekend.